Hello! In this video, I'm going to teach you, step by step, how to do a vibration measurement with Duo or Fusion. To begin with, you need a Duo or Fusion instrument and the WLS wireless sensor. Check that the version of the application firmware of your Fusion is equal to or greater than 1.2, or that the version of the application firmware of your Duo is equal to or greater than 2.2. Furthermore, you must have the V option, V as in vibration. Then, you'll need a computer, onto which software dBitrate version 5.5 is installed. Step 1. Set up the network card on the computer. Turn your sound level meter on by pressing the power key for 1 second. Then go to the main menu and confirm 1 time. Then press twice on the scroll button. This will display the Wi-Fi IP address and the SSID of the sound level meter. This information is essential to be able to get connected to your computer. On your computer, click on Start, then go to Control Panel, Network and Sharing Center, and then, in the side panel, Modify Card Settings. We are going to change the IP address to enable the communication with the sound level meter. Select Internet Protocol version 4, go to Properties, and then start by ticking box Use following IP address. Enter the IP address like on your Fusion, 192.168.1. Make sure you change the last digit. This will allow for a proper connection to be set up. Click on OK to confirm this operation. Step 2. Connect your Fusion. To access the sound level meter interface, log on like on a Wi-Fi network. Search for the instruments using its name, which is called SSID in the IT jargon. Then click on Connect. Check that the connection is established. Now, open your favorite web browser and enter the address shown on the sound level meter. By default, there is no password, so click on Confirm to display the DB Fusion interface. Step 3. Set up Fusion. Go to the Measurement Config tab and then create a new config by clicking on Edit and renaming the previous configuration. In the present example, I've chosen Vibration. Go to the Signals tab. Enable vibration recording on the 3 axes. With this sensor, we can record along 1 axis or all 3 axes. Tip: the vibration signal is already sampled to 12.8 kHz and always simultaneously recorded with an audio signal. You can adjust the sampling frequency depending on what you need. If you want to optimize your memory capacity, you could decrease it. For example, I've chosen 12.8 kHz. Click on Save. To enable the connection with the sensor, go to the System Config tab. Click on Networks. And then select Wi-Fi. Define the SSID name as WLS_, followed by the serial number of your sensor. Caution: make sure that the ad hoc box is ticked and that the IP address does not end with 1, as this is the address of the sensor. In the present example, I've chosen 1.2. Confirm to take the changes into account. Turn the sound level meter off by holding the power key down for 3 seconds. Step 4. Check the connection. Turn the sensor on. Turn Fusion on. Congratulations! Now you can see the WLS logo as well as the GSM one. For your information, WLS has an operating life of 8 hours. You can check its charge status with the number of battery bars displayed on the logo. 1 bar for a charge of 25%, up to 4 bars for a charge greater than 75%. Step 5. Prepare the measurement. Before doing a measurement, you should set your sensor on a rigid structure using a pasted base or the magnetic base of the sensor if this is a metal structure. Then screw the accelerometer on. Set the sound level meter according to the applicable standard. I selected a relatively simple case study, that of a train passing by. Let's now proceed with the measurement. Step 6. Measurement. Start the acoustic measurement using the circle key. Log start. Then start the vibration measurement by pressing the same key once again. The signal logo turns green. We are now acquiring 3 types of signals: sound level, vibration level, and the audio signal that will be used to play the measurement back like if we were using a tape recorder. When the measurement is completed, press the cross key to stop the acquisition. Step 7. Connect Fusion in USB mode. The fastest method to transfer your data in the dbTrade software is to connect Fusion to the PC using the provided USB cable. Step 8. Transfer the measurements. After connecting the USB cable and turning Fusion on, copy the measurements as easily as they were stored on a USB stick. The measurement is available as a folder named from the date and time or the start of the acquisition. The folder contains several files that will be used for analysis. Copy-paste the entire measurement folder into the appropriate directory on the computer. Step 9. Import the measurement into dbTrade. Open the software by double-clicking on the following icon. The following settings are required for the processing of the vibration measurement. In Preferences, select Opening Script. Check that the box is ticked. Create a new campaign by clicking on the icon showing a small white page. In AUX, then Spectral Analysis and Special Processing, select Configure Opening Script. Add one or several broadband spectrums, as well as one or several overall levels. In this case, add 2 overall levels. Choose your vibration data spectral analysis. For example, I've chosen third octaves for a range from 1 Hz to 500 Hz, and then tick the full octaves box. Then click on OK to confirm. Now edit the overall level by adding the weighting frequency of your choice, as well as the type of signal to observe. You can adapt these indicators based on the standard you want to apply. Here, I've selected WM frequency weighting and a LEQ time weighting for the first overall level, and for the second overall level, a linear frequency weighting and a peak time weighting. Now go to File, Open, then go to the directory containing your measurement, and open the file with the .cmg format specific to dbTrade. Step 10. Analyze the measurements. In the Results menu, select Spectrum History. Right-click to select the spectral channel to analyze. In the present example, I chose the Z-axis. Here, a dB display would be more efficient because we are going to display in parallel the time history of the acoustic measurement. We can then display at different moments of the train passing by the vibration spectrum depending on the time history of the acoustic signal. Finally, using the cursor, you can display the acceleration level for a specific frequency. Thank you for your attention. However, if you experience difficulties while operating our products, our technical support team will be happy to provide you with its assistance. Please feel free to contact us by phone or by email from Monday to Thursday from 8:30 to 12 and for 1:30 to 5:30 and on Friday until 4:30. Enjoy your measurements. Goodbye.